In dependency injection, we typically put our dependencies in the constructor. When our class is created, our dependencies get created and injected. However, there are times when we want to create our dependencies more often or in a different way. One solution for this is the factory pattern. In this video, we're going to look at how to create factories for our various needs in C#. We will look at an abstract factory, a factory for initializing class instances with startup data, and a factory for instantiating different implementation classes based upon passed-in parameters. With each solution, we'll be implementing it inside of dependency injection for proper handling of dependencies. Now, if you don't know me, my name is Tim Corey, and it's my goal to make learning C# easier. I do this by providing videos here on YouTube multiple times per week. Plus, I have a weekly podcast called Dev Questions. I also provide courses on C#, web development, and much more on IamTimCorey.com. The profits from those sales are what pays for the free content here on YouTube, so that everyone can have a great education in C#, not just those who can afford it. Now in this video, as with most of my videos, I'm going to create some source code. If you'd like a copy of the source code, use the link in the description below. Let's jump over to Visual Studio, and we're going to create a new Blazor server project. And that's just simply because Blazor server has dependency injection already set up, and we have pages that we can very easily modify. So let's hit next, and we're going to choose to call this our factory. Factory pattern is the name, and factory pattern app. How about that? Then we hit next. Yes, .NET 6, no to all any changes here. So we're going to leave this all as defaults and hit create. Okay, once this is created, we can close down the main page here. Let's start by creating a folder called sample. So this is going to be very much a demonstration video, not a do everything exactly the same in production. And the difference here is because I'm going to create really simple little classes to show off the different ways of using factories. But you're going to have to figure out what your classes really look like, because I don't want to create a whole bunch of complexity that we don't need. Okay, so I'll point out the differences versus real life, I guess you'd say. But the differences really are about the actual code in the classes we're creating. So we're going to create samples. Just to be very clear, these are samples we're going to use, and we're going to create a class in here. And this class, let's just call this sample1. And we'll put a semicolon here to change it to a file scope namespace. And for sample1, I'm going to put one property, and let's create a date time property and call it current date time. And we'll say equal new date time dot now. Like so. And actually, it's going to yell at me. Does not exist in the date time. That's because I said new. There we go. Datetime.now. So that just gives us the datetime.now. Actually, let's do this. Let's just do a toString and keep our keep it easier, which means this should be a string. Okay, and what that's going to be is just a clear string that is the current date and time. So whenever this gets created, we're going to see the date and time for when it was created. That's it. Okay, so when it's created, we're going to get this, and it's going to put it into this value. Now let's create an interface for this, extract an interface in the same file called sample1 or isample1. And again, this is where, again, I would not put this in the same file, but this is a sample. So that's why I'm doing it in the same file. So now we have our interface and our implementation like this would be a real class. But again, this is just for demonstration purposes. So let's come down here to our program.cs. We'll add a using up here. So using factory pattern dot samples, like so. And then in our services, we're going to add builder.services.add transient, which means get a new one every time for the I sample one, and the implementation is sample one. So whenever we ask for an I sample one, we get this implementation sample one. This is Dependency Injection 101. I have a whole video on dependency injection. I have a whole course on dependencyinjection.net that would be helpful. But this is just adding one dependency to our dependency injection. So let's go over to our pages. We'll go to the index page. We're going to clean up this page. We're going to get rid of most of this stuff. And we're going to have an injection here. So we're going to say inject. And then we'll say, I want to inject an I sample one, which I can add a using statement for here, or I can come down to my shared imports and say using factory pattern dot samples. I'll be doing multiple of these, so it's makes sense to do. And we'll call this sample. So I have my sample one, and here I can say right below hello world, let's do an H2 that says sample dot current date time. So this prints out whatever it said from sample one. All right, so let's make this run just to see that it works and just see we have a dependency that's in fact being called by dependency injection. And there we go. So we have our dependency, it's working, it's generating for us a string. And if we come, notice it's 213.27, it's 213.27, 213.39, there we go, 42, 44. So every time I go back to the page, it's a different value because of the fact that it's getting a new value from dependency injection. So that's what the add transient does. However, what if I wanted to have this, get this value or get an instance of this I sample one more than once on this page? So if I came down here in the code section and I said, every time I click the button, I want to, let's put a button down here. Class equals btn, and let's just say btn primary. And we'll say at on click equals, we don't have a method for this yet, we will. Let's call this get new time. And we'll have the get new time method, private void get new time, like so. And oops, there we go. So this method, what's going to do is get a new version of this time. And so we'll put down here, some way of, we want I sample one, and we're going to call this current time. And we'll make it nullable. But every time you click the button, I want current time to be equal to, I guess, sample. Like, how do I get a new version of this? All right. So I want a new version of this every time. And then what I'm going to do is, instead of showing up here sample, I'm going to say the current time. So if I were to run this and wait for it to load, well, first of all, it says object reference not set to an instance of an object. Of course, I can do this. That says, hey, if it's not null, then do this. I could wrap it in an if statement. That would be better for what we see in Blazor, but that's okay. So get new time. Okay, so got a time. Cool. I click the button again. As many times as I click it, it gives me the same value over and over again because I'm getting the same, it's the same instance. I don't have a separate instance. So how would I get a second instance from my dependency injection? And this is where people often get stuck with dependency injection. They say, oh, I don't know. Maybe I'll have to just say, create my own instance where instead of doing this, I would say equals new, and I would say sample one, like so. And if I did that, in theory, it works. So if I say hello world, I click it again. Notice it's 8 now. Now it's 00, 01. I'm getting different values. But the problem is I have now instantiated this manually. I have taken it outside dependency injection, and I'm not declaring my dependencies up front. And this is not a good thing, because now if sample 1 had dependencies, they wouldn't be pulled from dependency injection either. So that creates a whole mess. We don't want to do that. So how do we get a new instance from dependency injection properly? Well, there is a way of doing that. It's called a factory. And a factory, its job is to create instances properly from dependency injection. Let's do the very, very simplest version of a factory. So we have over here we've referenced the sample 1, right? Well, let's add one more. Builder.services.add singleton. We don't need any more than a singleton. I'm going to ask for a func of type isample1. And I'm going to close this out like so. And then I'm going to say in here, x arrow, open close paren, arrow, x.get services for isample1. Let's unpin this so you can see the whole thing. Like so. And then I need to put open close paren at the end, like so, and a semicolon. Now it's yelling at me right here because it could return null, which I'm going to say, no, it can't. That's the exclamation point. You saw my previous video on how to handle nulls. This is one of those instances where we know better than the compiler, because we know that, yes, there is a sample 1 in the services. Therefore, it's not going to be null. So what is this? Well, this is technically a factory. Now, it's the very simplest of factories, and it's a little bit complex to read. So let's talk through what it is. Now, if you don't know, a func, what its job is to be what's called a delegate. And a delegate, I have a whole video on delegates here on YouTube, but a delegate is a method that you pass around like a variable. And the purpose of it is to allow somebody else to call the method. You don't call a method right here, you let somebody else call it later. So this method right here, this is saying, hey, put this in dependency injection. So when you ask for a func of isample1, then you get back an instance of this, which this has one method, which has no parameters. And its job is when you call the method that it actually goes out to the services and gets an isample1. Okay, so it still uses dependency injection. It still declares its dependencies right up front. But what this is doing is allowing you to create this later, because this does not get run when you put it in dependency injection. It gets run when you call it. Let's see this in action, because I know it's a little bit confusing. So this func of sample1, okay, we're going to copy this. And over here in our index, instead of asking for an isample1, we're going to ask for func of isample1. We'll call it factory. I'm going to say down here, factory, execute that. And that's what the parens are for. Okay, so this is a delegate that's being passed in. It's a func of isample1. It's a delegate. We can call that delegate, call that method here. So by saying we pass in factory as the dependency that's been injected, and we're now running that dependency, which gives us current time. Yes, this is a little bit confusing if you're not familiar with delegates and how they work. Hello world, get new time. Okay, we're 21:27, 21:30, 21:31. But the difference here is these dependencies are coming from dependency injection. They're not coming from creating new instances manually. The difference is that if we had a dependency inside of sample1, that it would be resolved through dependency injection. So we can still have dependency injection throughout our application, and yet we can get an instance whenever we want of that iSample1. Now, let's be clear here before we go on, in that this is not something that you do all the time. This is something that you do in the rare cases where it's necessary. There are a few times when factories are necessary. In fact, if you've worked with calling APIs inside of your C# application, you've probably used the HTTP client factory because it creates HTTP clients for us and it handles their lifespan, reusing them, closing them out properly, and so on. That factory creates for us HTTP clients using dependency injection, but doing so in a way that does some work on those dependencies for us. So there is a case for it, but it's not an everyday thing. So be careful when you're learning something new like this, that you don't just say, oh goodness, I'm going to use this everywhere. I want to create new models, for example. Well, probably models shouldn't be in your dependency injection because models are just like data holders. I mean, you don't put int and string in dependency injection. You just create int and string. Well, it's no different really with models usually. Now, there's cases where, yes, a model might go into dependency injection if it has some logic in it or other things like that. But just be very careful you don't overuse this, okay? So with anything new, don't think that just because you have a hammer doesn't mean everything should look like a nail now. So this is just a new tool for your toolbox if you haven't used factories already. But let's dive deeper into how to create an abstract factory, because this right here, it's a little complex, okay? And it's a little complex to see where you're saying func of iSample and then calling it here. This is not as clear as it could be, and there's ways to make it clearer. So let's do that. So we're going to create a factory. Now, what I'm going to do is I'm going to put this into, let's go to a new folder here. And we're going to call this factories. And I'm going to put the factories in imports.razor, which actually nothing exists in factories yet. That's okay. So it'll yell at me right now because there's nothing in there. We'll get one in there. And we'll also put this as a using in here. Oops. There we go. And again, it's going to yell at me until I put something in here. So let's put something in here. We're going to create a new factory. So let's call this abstract factory. All right. And by the way, now program.cs doesn't yell at me anymore, and neither does the imports because I actually have something in that namespace. Okay. So we have our public class abstract factory. Now, I'm also going to create other things in here, other classes in here at the same time. And that's something that, again, I want to point out that normally I create these in separate files, but I want to keep it all together for you so you can see everything in one spot for this demo, because we're going to do multiple of these factories. So let's come up here to the top, and I'm going to create a public static void add abstract factory. Okay, and this is going to be an extension method. But first, it takes in two generics, T interface and T implementation. And then let's unpin this. Let's close that out too. We're going to say this iService collection services. And then we're going to have some limitations on our two generics. So this could be T and U, but I call it T interface and T implementation to show that these are generics and the first one's going to be an interface, the second one will be an implementation. So where T interface is a class, and then where T implementation is a class and it's a T interface. All right. So for instance, just to make sure we're on the same page here, if I passed in isample1 and isample1 and sample1, that would work, because isample1 and sample1, well, isample1, it technically is what's called a class, even though it's an interface. But the implementation is of type interface. So sample1 is an isample1. All right, so that's limitations on our generics. If you've not dealt with limitations on generics, yes, you can say what they can or cannot be. And you have some limited ability to kind of dial in what they can or cannot be in that particular generic. Now, inside of this public static void, again, this is an extension method on the iService collection. So we can extend the services here. This just makes things easier. We could do it all right inside of our services. We're not going to. We're going to do it all here to make it clearer. So we're going to create or fill this out. So first of all, we're going to say services.add transient IT interface, TI interface, and T implementation, like so. So that this right here is the equivalent of this line right here. It's going to do the same thing, but that just guarantees that we actually have that implementation in our services collection. Because then we're going to say services.add singleton and func of T interface. This look familiar? X arrow, open close paren, arrow, x dot get services, or get service, T interface, open close parens. Yes, we know it's going to be in the dependency injection. So this func of T interface, that's what we did right here. Okay, but instead of saying func of isample, we said T interface. We don't know what's being passed in. This is an abstract factory. And then finally, we're going to have one more, and that is services.add singleton. And this is going to be an I abstract factory of type T interface. And then we're going to have a factory, an abstract factory of type T interface. Now, I probably have some missing, something, I haven't actually named these things. That's what's yelling at me. So let's create these. We have abstract factory. We don't have an abstract factory of that correct type. So let's create of type T. All right. And we can create an interface for this. Let's do this again in line. Public interface I abstract factory of type T. And then we're going to implement that here. Okay. And let's say I have an extra close angle bracket there. There we go. Let's clean this up a little bit since it messed up. Okay. So we have this line here, and I'm sure this is probably hurting your brain. So let's talk through what it's doing. We're adding a new class to dependency injection. It's a singleton. And the class, the implementation, is abstract factory of T interface. Well, we have an abstract factory down here of type T, which T and T interface, it's the same thing as just a generic. Okay, so in our case, let's just bring in these two lines here just as comments. So I'm going to say here, just so we can see what this might look like. So if we were trying to do these two lines here, we'd be saying, I want builder.services.add abstract factory of type isample1, and sample1 is the implementation detail. Okay, that's what we'd be doing to call this. So we'd say add an abstract factory of type isample1 and sample1. So there's the interface and the implementation. So T interface would be isample1. So down here, we're saying, I want you to have an I abstract factory of type T interface. Well, that's sample1. And then the abstract factory is of isample1. So down here, we'd be passing in isample1. So what do we do here? Well, we're going to have a constructor, our abstract factory, and we're going to pass in a func of type T, and we're going to call this our, let's call it factory. And let's do a control dot here to create and assign the field. So now we have this private read-only func of T. Remember this, it's the same thing we did before over here where we said func of isample1, and we just called this method. So the factory got created, we just called it. We're going to do the same thing inside of this class. So let's create a method, public return type of T, create. And we're going to say return and run the factory. So we have this factory here, which is a func of T. We're going to return the execution of that, which returns the actual object. So we've returned the object that it's creating, which in this case, that func of T is going to create a service of type T interface, which in our example is isample1, which returns an instance of sample1. So it's the same work we did here. It's just we put it inside of a special class called abstract factory that has a create method. And the reason for this is it makes it a little simpler and easier to understand. Yes, this code is a lot of generics and delegates and interfaces, oh my. But once you kind of grasp it, once you wrap your head around it and take your time wrapping your head around it, don't worry if the first, second, third, or fifth time this is confusing. Take your time. Walk it through step by step over and over again. Sometimes it's best just to create it, just to do it, and then in practice, not in production, in practice, and then walk it through over and over again and, step through the code. But what that's going to do is create for us our new T, whatever that T is. In this case, our isample1. Now, for our interface, we actually have to move this down. So T create. That's the only thing in the interface is just the create method. So now we have this, this public static void that is going to add these three things to our services list. Now I do have one issue here. This is yelling at me here saying, hey, the namespace cannot directly contain members such as fields, methods, or statements. And yes, I have missed one step. Let's cut this out and say public static class abstract factory extension. Okay, because I have to have this method inside of a class. It has to be static in order to have a extension method. So I just missed making it a class. So we now have this abstract factory collection or abstract factory extension, which is just a class. We don't need to even worry about what the name of it is. But this method right here will allow us to create an abstract factory. So let's go back, let's save this, and let's come back here, and we're going to comment out these 2 lines. We don't have them anymore. Okay, and instead we're going to say builder.services.add_abstract factory. Now, if you don't see that in the list, it's probably because you didn't add the using statement up here for it. I'm going to add an abstract factory for I sample1, and sample1 is the implementation. So this looks very, very similar to add singleton or add transient, but now it's add a factory for this, which is going to register these as transients. Okay, it's going to do that inside the method. It's also going to register our func, and then it's going to register the factory itself, which calls the func. So let's see how to work with this inside of index.razor. So let's get rid of this. Let's actually just get rid of it. And / doesn't work in Razor anyways. It's actually the, there's a couple different ways of doing, comments. That's the word I'm looking for. But instead we're going to say inject I abstract factory of type I sample1. We'll call this factory. All right, so we've injected now an I abstract factory of type I sample1. So we're still being very clear as to what we're depending on. And then down here, we're going to say factory dot create. And that factory creates an I sample1. So that's our sample1 right here. Now, if we run this and wait for it, we have hello world. We have our time. We have our time again. We have our time again. Every time I click the button, we get a new time. So it still works the same. It's just it's very clean right now, where we just ask for a factory of it and hit the create button. The cool part is that it's super simple. It's super simple to add here, and we can add this for as many different types as we want. Let's just say we created a sample2. So let's go to samples. We're going to say add class sample2. And let's put our semicolon here. And for public class sample2, we're going to have a, let's do the same thing as sample1 because, why not? But the current date time, we're going to do it a little differently. Actually, let's do this. Let's do a random value here. Prop, string, let's do an int. Random value. And we're going to say constructor. And we'll say random value equals random.shared.next. And we'll say from 1 to 100, which actually, just so you know, I always say this, but max value, you'll never get 100. You only get 99. It's up until the max value. So you'll never hit the max value. You're always one shy of the max value. So if you want 100 included, you have to say 101, just so you know. So that's a random value. And then we'll do a control dot to extract the interface. We'll do the same file again. Again, this is a sample. So we have our int random value. So now, if we want to create this in a factory, well, we go to program.cs and we say builder.services.addAbstractFactory I sample2. And then over here on index page, we can say inject I abstract factory I sample2. We'll call this sample2 factory. And we'll say the H2, let's get our I sample 2 nullable random value. So we'll say here at random value if it's not null and the random value. Just we have that. Let's put in front of it the random value is that. Okay, so down here we don't have anything, but in our get new time, let's use the same button because again, this is a sample. So random value equals sample 2 factory dot create. Let's run this again. So I didn't have to rewrite that abstract factory. So get new time, there's the random value, there's a random value, there's a random value, there's a random value, and so on. So every time I click the button, we're gonna get a different random value. Even if I click it multiple times in a second, I can get a different random value every single time. And just so you know, I want to point this out real quick. Random means random. That means you might get the same value more than once in a row because it has the same opportunity to have that same value come back up as it did the last time. So just so you know, some people think that random means it'll be a different value every time. It can be the same value, and that can be the random result. So just to be clear, there's actually an issue, I believe it was Spotify had to change the way they did their shuffle because people thought it wasn't random, when in fact it was so random that sometimes songs would play twice in a row. So they actually had to change their shuffle for that. So just clear that up about random. All right, so we've seen abstract factory, and the abstract factory works really great if all you want to do is get a new instance of something. So every time you ask for it, you say create, and it gets a new instance of it. But there are times when maybe you want to create an instance that is pre-populated with some information. So normally you're used to having a constructor where you pass in data. But with dependency injection, your constructors pass in the things you want from dependency injection only. So how do you pass in data to a constructor? Well, that's quite confusing to people. Let's create a factory that's not an abstract factory. It's a factory that is custom built for one particular type that is designed to give us data inside of our class at startup. So let's do that now. Let's start by creating a new entry in samples, and we'll call this user data. Now, this class right here is going to represent a class where you need to initialize it with certain data already in it. And the data we're going to talk about is name. That's the only thing we're going to put in here, but that's going to be how this class needs to be initialized. The class needs to have a name populated in it. Now, typically, this wouldn't be just a model. It would have methods attached to it as well. But in this case, we're just going to put one property in here to kind of stand in for any class that needs data brought into it at the start. So we're going to say, let's make the name nullable. Oops, there we go. Not there. String question mark, there we go. And we're going to say, let's do control dot here, extract an interface in the same file called iUserData. And it just needs a name. That's it. All right. So that's the whole setup for user data. That's our sample data. Then we're going to come over here to we had an abstract factory. We call it abstract factory extension. Let's create a new class. We'll call this let's call it generate class with data factory. How about that? It's a great name, I know, but this at least gives us some information on what it's doing. We'll call this extension. So just like here, we have our public abstract factory or add abstract factory. We're going to have our add generic class with data factory, like so. But we're not going to get there yet. Instead, what we're going to do is come down here below, and we're going to create our factory first. So public class, and we'll say user data factory, like so. And then we're going to have a constructor that takes in a func of iUserData, which control dot to add the using statement for that. And we'll call it, what we call it over here, we called it our factory. So let's just call it factory as well. And then control dot to create, assign that field. Okay, looking very, very similar to what we had before. And we're going to say public iUserData create string name. Okay, so this is the create method, but we're taking in a name. Var output equals, and call that factory. So that creates the instance of our object, but that instance does not have data in it yet. No problem. We're going to say output.name equals name, and then return output. So you can see what we're doing here is we're creating the instance, but we're creating it into the factory so that when you pass this in, we can then update the instance with that right away, and then we can return the instance to you. So that's our factory. So let's do a control dot here to extract an interface in the same file. And that's our interface that just has the one iUserData create method. And now we can get to actually setting up our method here. So we can say public static void, and by the way, this needs to be static class. So add generic class with data factory, and we're going to pass in this iService collection called services. Let's unpin this so you can see the whole thing. And we're going to say, just like before, services.add transient iUserData. See, the difference is we're not using generics here. And pass in user data. Whoops. And then services.add singleton func of iUserData. And then we're going to say the same exact method, x.get services of iUserData. And yes, we know it's going to be not null. And then finally, services.add singleton. And this is going to be the iUserData factory and the user data factory. So if you look over here at these three right here, we'll just copy these and come over here and we'll comment them out. These three right here are the same as these three right here. The difference is, okay, they're almost the same. The difference is that instead of using a generic, I'm using a specific class because this deals specifically with iUserData. And the reason why it's specific to that is because the factory has some specific code that only works with iUserData. And that's this line right here and the parameter being passed in. But that's it. So the rest is the same. And we can just say, we can call this over on our program.cs, builder.services. Add our generic class with, or add generic class with data factory. So we're not passing in what specific types because that just takes care of the types for us. It's the iUserData. So it still uses dependency injection. It's still adding this to dependency injection. It's still requesting that from dependency injection with our func, and it's still adding our factory to dependency injection. The difference is that it's only for one. It's not an abstract factory. It is a more concrete factory type. So now with this concrete factory type, we can request an iUserData factory. Let's go over to our index.razor and let's inject our iUserData factory and say user data, like so. And now we can ask for we have our iUserData, and we'll call it user. And again, we'll make it nullable. And then the same button here. Actually, no, you know what? Let's do this on startup. So protected, override, uninitialized. And we're going to say user equals, and we have our user data factory. So user, let's call it user data factory. So we're clear here. So user data factory dot create, we have to pass in a name. So Tim Corey, like so. So now we can put up here hello at user dot name. All right. And yes, we'll make this do nothing if it's null. Let's run this. Wait for it. And it says, hello, Tim Corey. Because this came from dependency injection, but then was added to based on what we passed in. Every time you pass something in, so every time we do this, we could pass in a different value and get a different instance back with a different name in it. So that's a way to have a non-generic, non-abstract, but a factory that we pass data in to instantiate our class. Now, there's another thing we can do here as well, and that is maybe we want to get a different version. So you ask the factory and say, hey, I want this interface, but here's a specific implementation I want if we have more than one. How do we do that? Well, let's implement that as well. So I can come over here and let's create a class, and we'll call this different implementations factory. And we'll mark this as file scoped, and we'll say extension, like so, make it static. And we're going to do something very, very similar to what we did before. So let's create a factory first. Down here, public class. And again, I just want to reiterate this. I know that I said this over and over again, but please create your classes and your interfaces all in their own files. Don't create them all in one file like I'm doing here. But this is great for a demo to keep everything together for you. So you can see the different pieces that go together in one spot. So public class, vehicle factory. Now, in order to have a vehicle factory, we should probably have some vehicles. So let's create some classes. I'm going to say vehicles, plural here, because in here, we're going to create multiple vehicles. We're going to create a car, and we're going to create a truck as well, and probably a van too. So let's start off with prop string vehicle type. We're going to say this is a car. This is one way of identifying classes, is by creating a property that identifies this. You could also say type of, if you want to go that far, in order to not have to look up what the type is through reflection. So we can just have a property that declares it, or you could do something else. But for this, we're just going to have the type of vehicle equals car and call that good. And then public string start, like so. And this method just return The car has been started. Okay, that's, again, very, very simple. Sample class. Let's copy this twice. And this is truck. The truck has been started, and this is a truck. Again, yes, this is not real life code because of the fact I could abstract this all the way into one class and yada, yada. That's not the point. The point is to give you a sample of how you could do it in real life with real code, where this would be different. So I have the car, truck, and van, and each of them has a vehicle type, which is truck, car, truck, or van, and each of them has a start method, which says that the whatever vehicle it is has been started. That's it. Now let's extract an interface in the same file called iVehicle. So we have our iVehicle, and we already know that all three of these implement it, so let's go ahead and apply these to all three. Now, what if you want to put this in a dependency injection? You have one interface that has three different implementations. We're going to see how to do that, and we're going to see how to do it even with a factory. So let's create a factory that handles creating these instances. So we have different implementations. Yeah, that's it. So we're going to create a constructor, and in the constructor, we're going to ask for a func of IEnumerable of type iVehicle, which control dot to add the using there. And we're going to call this factory. Control dot to create and assign the field. So our factory, and we ask for an IEnumerable of vehicle, which means it's going to give us a list or a set of vehicles. Why do we want a set? Well, because we're going to put all three in dependency injection. We'll see that. So for our public iVehicle create, we're going to pass in the name. And we're going to say var set equals factory. Actually, it's factory, which runs the creation there. It gives us a list or a set, an IEnumerable of iVehicle. And then we're going to say iVehicle output equals set where x arrow x dot vehicle type equals name first. So it's going to look through the list and find the one with the property that matches the name you've passed in. Now, I do want to point out that if you pass in, we're doing a string comparison, which is case sensitive, and we're doing a lookup on it. So if you pass in all lowercase car, it's not going to find it. And it's going to throw an exception because it says first. And we don't have that. So you would want to do a whole lot more work here around making sure that you're passing in either an enum and doing still some checks on that to make sure it's a valid enum, or doing something else for your lookup. But this will work for our demo. So we're getting our vehicle. Return the output. Okay, so that's our factory. Let's go ahead and create the public static void add vehicle factory. This iService collection, services. And we're going to add services. Add transient. iVehicle car. And let's just copy this line because we're going to do it 3 times. Truck. Van. Now, we're going to add these 3 things to dependency injection. And some people say, well, wait a minute, you can't do that. You got 3 different types. How do you ask for them in dependency injection? Well, if you'd asked for iVehicle, just one, you're going to get back van because it's the last thing added. But we're going to ask for an IEnumerable of iVehicle, which, notice right here, IEnumerable of iVehicle. And what that will do is it'll give us all the instances of iVehicle in dependency injection. So car, truck, and van. It gives all three of those. Now we can say services.add singleton. And it's a func of IEnumerable of type iVehicle. Nope. IntelliSense or IntelliCode actually got ahead of me there. So it's a func of an IEnumerable of vehicle, which means I need 3 closing angle brackets. And then I'm going to say our same, let's unpin this, we have a little more space. X arrow, open close parens, arrow, x.get service. And the service is IEnumerable of type iVehicle. And then we come to the end here, and we have an open and close paren and our semicolon at the end. And before that, we put our exclamation point saying, yes, we know this could be null, but it's not. Trust us, it's not. Let's actually put this in the next line down just to get us a little more space. So there's our factory. And then let's create our actual vehicle factory. So services.add singleton iVehicle factory. Oh, we didn't add an interface for this. Control.extract interface, current file, iVehicle factory, which just has the create. All right, like so. So now we have our singleton for iVehicle factory, which chooses the right vehicle to create for us. Which technically what it does, it gets all 3 from dependency injection, and it picks which one we want, which not terribly efficient, especially if you have 1,000 of them. You probably shouldn't. You should probably think of a different way of doing that. But if you have a couple, that might be a bad idea. Or you could go another route with asking for func of car, or in func of truck, and func of iVan, and then you get the right one from that. So there's different ways of going about this, but this is the simplest way. But yes, it does get new instances, since they're all transient. It gets new instances of all 3 of these and only returns 1. So if that's a problem, then you can go about a different way, like using the funcs. But with this, we now have everything set up. So let's close all of this out. We got a lot of tabs open. We can pin this again. We can go back to our index page, our poor index page was getting overloaded by now. And we're going to say inject, and this is I'm not sure what this was anymore. iVehicle factory. Yep. Vehicle factory. And we also have to add dependency injection. We haven't done that yet, I don't think. Nope. Builder.services.add vehicle factory. There we go. Add to dependency injection. Now over here, we can say I want an iVehicle. It's nullable. Vehicle. And let's do it on initialized. Vehicle equals vehicle factory dot create. We have to pass in the right string. That's magic strings and all the rest. Not the best, but it works. Let's say truck. And then up here, we're going to say, after username, who drives a, and then, no, let's do this. At vehicle question mark dot, we have the start method and vehicle type. Let's do vehicle type. And then we'll also have an H2 down here that is at vehicle question mark dot start. So let's run this. Wait for it to load. Hello, Tim Corey, who drives a truck. the truck has been started. Okay, we did that based on the fact we asked for a truck. Let's ask for a car instead. And Tim Corey, who drives a car, and the car has been started. So I get a different instance based upon what I've asked for. So I could even, I could change names, Sue Storm and Van, just to show you all the different options we could do. Hello, Sue Storm, who drives a van. The van's been started. And again, I can change, one thing at a time or both and get whatever instance I want back depending on what I ask for. So that's how you can use a factory pattern to get a specific instance based on what you request as well. So the difference here, and one of the things that some people say is, well, you know what? I could have done this a lot less work. What I could have done is I could have passed in, if we look here, let's go at the, doesn't really matter which one. You are, quote unquote, passing in the iService collection. That's our dependency injection container. And so you're saying, well, I could pass that container in, do a get service whenever I wanted. So I could just pass in iService collection to my index page without having to do all of these, and then I could just ask what I want down in the code. And yes, you can. That's more of a service locator pattern, which is actually an anti-pattern usually, not always, but usually. And the reason why it's a problem is because you bury in your code what you're depending on. Whereas here, we're saying exactly what we depend on. We depend on, in this case, iVehicle factory. And if you look at the vehicle factory, it depends on these three things, this and this. So it declares right up front what it depends on. So we have a clear dependency tree. We're using dependency injection. We're not using just a service locator pattern where we're asking for services buried in our code somewhere. We're very clear up front what we depend on. So that's the difference here. And this is why we use a factory pattern as opposed to just passing around that iService collection. Now, you may ask about this, where it's getting the service as in the method itself, but this is declaring up front what it depends on in our dependency injection. So it's being very clear. Now, the other thing I want to point out is I have not really buried, but I have put these behind extension methods. So when you look at program.cs, you see these three extension methods: abstract factory, generic class of data factory, and vehicle factory. But we don't have to. We could have taken the extension methods themselves. So this right here, we could have instead taken this code and put it right in program.cs in this spot. And that would have worked just fine. So if we take this, let's copy this. And if I were to comment this out, instead I would paste in this, which I have to change to builder.services. I could have done replace all, but no big deal. So this would work just the same as this. So if I were to run this right now, I've commented out add vehicle factory. I still see that Sue Storm drives a truck and the truck's been started, because that's all the extension method did, was kind of abstract away this into one method called add vehicle factory. It's even easier or nicer when you have the abstract factor, which is lambdas and generics and all the rest. You don't have to put it in your program.cs. You can just put that one line in. So one line, whole lot better, whole lot cleaner, and easier to use. Continue editing and stop. The thing was still running for some reason. So that's how to work with a factory pattern. Again, I want to be very, very clear here that this is something that you don't use every day necessarily. It's something that you want to first and foremost depend on what I'd call regular dependency injection, where you just inject the dependency at the constructor and then you do work with that dependency. But there are times when you need a factory where maybe you're creating something over and over again. One of the examples that I came across recently, which we're going to cover in a future video, is when you put WPF behind dependency injection. So we're going to have dependency injection in WPF, but there may be times when you create a form from another form over and over again. Every time you click the button, you create a new instance of a form. Well, you can't just put that in constructor injection because you need more than one instance. How do you do that? Well, you use a factory in order to do that. And so we'll do that with an abstract factory probably. So there are times when factory is necessary, and there are times when this makes sense. Just don't think that it's used every single day for every single project. It's not. This is one of those things where whenever I cover design patterns, I want to be very clear on design patterns. Design patterns are typically complex. And the only reason that you add a complex design pattern is if the complexity of the design pattern is less than the complexity of not using the design pattern. So don't think of design patterns as something you do every day. It's something you do when you have a complex situation that you need to make a little less complex and a little more scalable over time. But if it's not that complex yet, don't use the pattern. So I want to be very clear there with that. So factory pattern can be very, very useful. Personally, I like the abstract factory pattern a lot because when there are times when I need it, it's just drop in. I don't have to worry about declaring all or doing all the work into the pattern, the factory itself. I just say drop in the abstract factory pattern, and then I reference it. It's also very clear what dependencies it has right up front because I sample one and sample one. That's what it's depending on. So very clear. I like it a lot. The other two, there are times when they're necessary, but I really prefer to see the abstract pattern used. If you need to instantiate something with starter data, or if you need to have a specific class returned based upon what you're doing, there may be a better way of doing that. But if not, then the factory patterns here that I've shown will work well. All right. If you have any questions, leave them down in the comments. Maybe someone can answer them. Maybe I can. Well, it depends. But if you have any other thoughts on the factory pattern, I'd love to hear them as well. Thanks for watching. And as always, I am Tim Corey.